All right, this is page 6 of notes 1 of math analysis, and we are talking about trig in the plane. And to talk about trig in the plane, first we're going to need to know about angles in the plane. And so on the last page, we talked about rotating counterclockwise being positive rotations, rotating clockwise being negative rotations. Talked about some of the names that you'll give angles, and you can see here, we see we got an alpha, we have a beta, a theta, a phi, a capital A, and then a alpha sub 2 because it's the second alpha, I guess. So what we're going to do here is we're just going to sketch these in standard position. Let me see, I think I'm also going to convert them to whatever. I'm going to convert them from what they're in to the other angle just for practice. So let's see if we can do this. So you maybe don't have a lot of sense of how to draw these yet. Eventually it'll become second nature to you. What I'm going to do is, so like I do have an idea of what 60 degrees looks like. So 60 degrees would look kind of like this. So 120 degrees, if we went all the way to 180 degrees and then went back 60, we would be at 120. So I'm going to think of it that way. So think of going all the way to 180 and then back 60, it'll put you at 120. Basically, I'm going to try to base all of these on 30, 45, or 60 degree angles, or pi over 6, pi over 4, pi over 3 angles, depending on what we're dealing with. So here I'm thinking 60 degrees, but kind of like in the second quadrant. So I want to make a 60-degree angle with the negative x-axis. And the reason I'm doing that, I know I'm like over talking this one, but like if you get this one, they all kind of make sense. So let's see if we can do that. So here's 180 degrees. So I want to make sure that I get like a 60-degree angle with that. So I'm going to say that this is alpha. So the idea is that this angle here is 60 degrees. Like I wanted to draw my 60-degree angle, but in the second quadrant. I think that worked. So that's going to be that. And then if I wanted to convert this, so 60 degrees is pi over 3. And then pi over 3, so 60 times 2 is 120. So pi over 3 times 2 is 2 pi over 3. I'm going to say that alpha could also be 2 pi over 3 in radians. The other way to get that is to multiply by pi over 180 and cancel 120 over 180 is 2/3. You get 2 pi over 3. Either way, doesn't make a difference. All right, beta. So 225. 225 is bigger than 180. It's less than 270. So it's definitely going to be in the third quadrant. And also, 225 is 45 degrees past 180. So 45 degrees past 180. So this is 180. And I go 40. So the 45 degrees, the pi over 4 angles, are really nice because they split quadrants directly in half. So what I'm going to do is try to do that, as much as possible. I don't know. I went for it. So I'm going to say that this is beta. My betas just look like B's. I put almost no extra effort into that. You never get a problem where you have a B and a beta in it. Like you're tempting fate if you do that. Now the way that I thought about it was I thought that I went to 180 and then I went 45 past, right? So this would have been another 45, right? So based on 180, for the first one, I thought it's 180, but then 60 less than that. So that's 120. Then here I'm thinking it's 180, but 45 more. And that's the way you generally want to think about these. Now, there's a lot of ways to think about how to convert this. So you could do 225 times pi over 180, totally fine. 225 is 5 times 45, and 45 is pi over 4. So this is actually going to be 5 pi over 4. Because the ones you really want to memorize, this is hard to understand at first. You want to memorize the radians, right? Eventually, you'll actually maybe find it a little difficult to figure these out in degrees. That's when you're finally doing what you need to do. You'll be like, I wish I knew these in degrees, but I only know them in radians. Perfect. That's perfect. That's what we're looking for, really, which seems weird, but it is. So let's try the next one, 330 degrees. So a lot of options here. I'm going to say that this is not just 0, but also 360 degrees. And 330 degrees is 30 degrees less than 360. So I'm going to aim for like a 30. That's probably not right. Maybe there. So I'm going to say that, whoa, my bad somehow. I don't actually know what I did. I'm going to say that this angle is my 330. Uh-oh. Are we crashing? I hope not. Come back. Yeah, okay. So I'm going to say that this is alpha. Nope, theta. Sorry, theta. And the reason that I put it where I put it is that this angle, if we kept going, would be 30 degrees. So that would give us, if we had another 30, we would end up at 360. So this should be 330. 330 is 11 times 30. And so 30 is pi over 6. So this is going to be theta equals 11 pi over 6. You can multiply by pi over 180. That's another option. A lot of options there. So let's take a look at the next one. So 420 degrees. For obvious reasons, I've always regretted that I used 420 degrees, but I did. So 420 degrees, let's think, like, what is that? So it's bigger than 360. So I'm going to say it's 360 degrees, but what bigger? How much bigger? It's 60 degrees bigger, right? If I had 360 degrees and added another 60, I would be at 420. So what I'm going to do is I'm basically going to draw a 60 degree angle. I'm going to try to draw that. And then to make this work, I have to go 360 degrees and then another 60. So first, let's go 360 and then another 60. So this is alpha sub 2 or alpha 2, depending on how you want to say it. And the reason that that worked is we went, how am I going to indicate this? We went a full three, I don't know how I want to indicate this. I'm just going to show that this little extra part here is 60, right? Go one full lap and then do another 60 degrees, and then you're there. How can we convert this? Well, you can do the thing, right? Times pi over 180. That's like the normal thing to do. Nothing wrong with that. But I would rather kind of think it through, because the more you play with the numbers, the easier it gets. So I'm thinking 360 degrees I know is 2 pi. And then 60 degrees I know is pi over 3. Threes are so hard to draw on here, and I don't know. It just could be that I'm bad at drawing threes, but like in particular, I struggle with threes on the iPad. So this 6 pi over 3, so 7 pi over 3. So it's nice to just like get your number sense going on these and like play around with them a little bit. I recommend it. Obviously, that's why I'm doing it. Negative 30. So negative means clockwise and 30 degrees. So I just want to make a 30 degree angle, but clockwise, right? So I want to end up like here. So now it's really important that I label this correctly, because hopefully even now your inclination seeing this picture would be to do this. Hopefully that's your inclination. Don't do it, because we know this is negative 30, but that should be what you want to do. So I'm going to say that this is angle A. And so like, I mean, that's just 30, like that's done. I'm going to do something weird though. I'm going to just show you that we could have done this, and this would have been how much, right? So you were at 360, you were horizontal, and then you went 30 the wrong way. So you like lost 30 degrees. So this would have been 330 degrees if we had rotated that way, but we didn't. So to convert this though, we have this memorized, hopefully. It's just going to be the negative of pi over 6. So that's a nice conversion for us. Let's take a look at the next one. So negative 720. Negative 720. All right, so 720 is a multiple of 360, which means this is just like full rotation. So if I start at 0, and then I go one full lap, and then go another full lap, I'll be at negative 720. So it's actually this. That's not very thick though. So, you know, whatever. Let me shade this in a little bit. Let's say this, and I'll put the arrow. So now I need negative 720. So negative 360, negative 720. So this is phi. That's bad phi. Phi. Okay, that's phi. To convert, I don't really have more to say about that, because it forms an angle of 0, like with the x-axis. So there's nothing more to like do there. Convert this though. So 2 pi is one full rotation. So negative 2 pi is one going clockwise. And then we went 2 of those. So this is going to be negative 4 pi. So we're practicing several things. We're practicing converting, and we're also practicing drawing our angles. They're both super important skills, so try to develop them as much as you can. All right, what can we do here? So you probably want to just convert it. Everyone at the outset wants to just convert everything to degrees. Fight the urge. Let's see if there's something else we can do. So what is this? This is 6 pi and then plus pi over 2. What is it? 6 pi over 2 plus pi over 2. Let's break this down. 6 pi over 2 plus pi over 2. I don't know why I wrote those at like different heights. That's weird. It's all falling apart. You know what? I'm just going to rewrite it. Looks too gross. Here we go. Okay, so plus pi over 2. This definitely works. So that's 3 pi plus pi over 2. That's what I was struggling to say before, I think. All right, what would 3 pi look like? Well, 3 pi, I want to go, this would be pi, and then, ooh, look at that. It became a trapezoid. Is that always going to happen? How did I even do that? Nope. I have no idea. I have no idea how I made that happen. All right, here we go. So it's going to go pi, 2 pi, 3 pi, add another pi over 2. Should I do it again? Let's do it again. Here we go. It's pi, 2 pi, 3 pi, and then, what? Let's try it again. Okay, follow along. Pi, 2 pi, 3 pi, and then another pi over 2. So we actually have ended up right here. So that one's really interesting to me. So first I went pi, which is half a circle, then another pi, which completed one circle, another pi, which is another half circle, so another top half kind of, and then just half of that, so a quarter of a circle. So we ended up here. This is ending up in exactly the same place as which angle that you know. There's one angle you know that ends up there. So this, it's basically the same as 3 pi over 2. Angles that end in the same place are called coterminal. They terminate in the same place. They share a terminal side. Coterminal. This angle is coterminal to 7 pi over 2. Actually, we could have talked about that in a lot of cases. Up here, 420 degrees is coterminal to 60 degrees. It looks like a 60-degree angle, but for some reason we called it 420 degrees. Here, negative 30 degrees and 330 degrees terminate in the same place. They are coterminal. Negative 4 pi and 0 are coterminal. So coterminal angles are actually kind of a big deal. If we wanted to convert this, which is unrelated to coterminal angles, I just decided we should convert it now. What is the easiest thing to do? Well, I guess you could do any number of things, right? So 3 pi is 3 times 180, so 540, and then pi over 2 is 90. So this is actually 630 degrees. That's one way. You can multiply by 180 divided by pi, and that would convert it. You could convert, I don't know, 3 pi over 2, and then like add something to that. Like any number of things. A lot of things you could do. Let's take a look at this. 11 pi over 4. How can we break it down into useful things? Well, 2 pi is very useful because it's a full circle. So 2 pi would be 8 pi over 4, which is basically what I'm looking for. I'm looking for multiples of 2 pi whenever I break this up. 8 pi over 4, and then another 3 pi over 4. So I need to go one full circle, and then 3 pi over 4 beyond that. I know where 3 pi over 4 is. 3 pi over 4 cuts this quadrant directly in half. Now to do the angle though, this is alpha prime, which sounds pretty cool. It sounds like a transformer type thing. We need to go full circle because of the 2 pi, and then we need to go another 3 pi over 4. So full circle, and then another 3 pi over 4. This is alpha prime. So what is alpha prime coterminal to? Coterminal to, well, it's going to be 3 pi over 4 because that's the angle between 0 and pi over 4 that 0 and 2 pi that we recognize that it terminates with. It's actually coterminal to an infinite number of things because you could keep going around and around and ending there over and over and over again if you wanted to. So finding coterminal angles is a big deal. We're going to do a lot of that on the next page. But like start thinking about that, right? Let's see if we can convert this. I think the easiest thing to do here is to say that 8 pi over 4 is 2 pi. 2 pi is 360. And then 3 pi over 4 is 3 times pi over 4. Pi over 4 is 45, so this is 135. And then we can add those together to get 495 degrees, I guess. I think. I'm not using a calculator, so good enough, right? All right, how about this one? So I can think of 2 ways to do this. So you might say, 2 pi written with a denominator of 4. This is a skill you want. 2 pi written with a denominator of 4 is 8 pi over 4. 2 pi written with a denominator of 7 is 14 pi over 7. 2 pi written with a denominator of 11 is 22 pi over 11. Being able to rewrite 2 pi as something over its denominator is huge. It's always 2 times the denominator over the denominator times pi. Not like groundbreaking, but very useful. So I think that I look at this and I say that this is definitely 8 pi over 4 plus another 7 pi over 4. And I actually know what to do with that. Basically, you want to do it in a way where you know what to do, right? So here, 7 pi over 4, I know, cuts this quadrant in half. I feel like it should stick it. There we go. I think it sticks at pi over 4s. I don't know. It's really hard to say because the lines aren't the same length. But I need to go 1 full circle and then another 7 pi over 4. So full circle, 7 pi over 4. So this is going to be beta prime. Crazy. Another way to do this is to look at it and think that 15 pi over 4 is like almost 16 pi over 4, which would be 2 times 8 pi over 4. So 2 times 8 pi over 4. That would be 2 full rotations, but then that's too much. I'd have to subtract pi over 4. So negative pi over 4, if I had graphed it, would have just been this angle. This would be negative pi over 4. So this angle is, there's 2 good angles that we could say that it's coterminal to. So I'm going to say coterminal. It's first going to be coterminal to 7 pi over 4. What is happening? What am I trying to write? I think I want it all in the numerators. What? 7 pi over 4. Also negative pi over 4. Either of those is good. 7 pi over 4 is the one between 0 and 2 pi, so it's called the principal coterminal angle. There's an infinite number of angles that are coterminal to this. Every time you end there, you're coterminal. The principal coterminal angle is 7 pi over 4. That's the one people would want to think of when faced with this angle. And then I guess we should convert this. So how to convert it? I know that 8 pi over 4 is 2 pi, which is 360. And 7 pi over 4 is 45 less than 2 pi. 45 less than 360, I should say. I think of them interchangeably. It's crazy. So that's 315, or just memorize it. Also an option, which would be 675 degrees. All right. So just to review, let's fill in our angles in radians here, and then we will stop the video. So we're just going to kind of go for it. So we got this. So you want to be pretty quick at this because there's more to come, right? So like more that we're going to want to fill in here, which means that you got to be quick about this part so the other part can also go fast. So hopefully you're starting to know them. I kind of stuttered there on that one. Don't worry, I'm back, I think. Okay, so these are our famous angles. You got to know them like really fast. Start memorizing them if you haven't already. I'll be back in the next video and we will keep doing this. So I will see you there.